Okay, okay. Yes, thank you. And yeah, thank you very much. Sorry, it's a big mess. Every Friday is bad, and Tuesday is okay. And okay, now we start. And so let's quickly go through the points we have already covered in last class. At the end of last class, and I think this is funny, right? So one student asked a very good question about the procedure of formulating the so-called exchange optimal for such a simple two-person, two-goods exchange economy. And the student, the question she asked is why we have this term. I explained very shortly at the end of last class about why. And here, let me, here I added a couple of more lines to explain. Also, I put this file into the model. So therefore, everybody can go through these several sentences for explanation slowly and more carefully by yourself. So the idea is we try to figure out, what happened at this point, okay? That's what we are doing. But here, we slightly change the problem by considering what may happen here. And the reason is, I will explain shortly. Still need to draw something. And here we effectively consider what happened at this point. That is, at this point, the indifference curve for Alice and the indifference curve of Bob, they are tangent at this point. And pretty much like what happened here. You know, at this point, again, also the case, the two persons, the girl and the boy, they have the same marginal rate of substitution. That is the two curves, the indifference curve for Alice and the indifference curve for Bob. They're tangent at this point. And at this point, we graphically and also economically, we know they share the same marginal rate of substitution. And then now we want to prove, we want to confirm that intuition or economic intuition or graphic illustration by mathematics. How to do that? And if we starting from this point, it's very hard to identify this point. So therefore, we do this job slightly different from original question. And we consider what may happen here at this point. At this point, what happened? The two straight lines also in tangent with each other. And so therefore, we move along this curve for Alice. Sorry, for Bob. Make sure Bob will not be worse off. Bob will not cry. At the same time, we maximize the utility of Alice. As far we maximize her utility. That is, we consider how to make this girl happy as possible, and the constraint, the boy will not cry. In other words, here we joke that we take, let me see where is it, and here we take Alice as our queen and Bob as nobody. So therefore, we make sure, Bob, please don't cry, okay? And then let's turn to Alice. Take Alice effectively as a queen. We please her, 我们讨好她, okay? And as much as we can by changing the allocation for products in a way that Bob will not cry. At the same time, we maximize Alice's utility. And also we can take Bob as a kind of king. Please him as far as possible and fix Alice's utility. And then if we do that, we are effectively, considering what happened at this point. Sorry, this is the indifferent curve for Bob at this point. So therefore, what we are doing, we are trying to figure out what happened along this curve. This curve is the collection of all such points. At each such point, the two indifferent curves are tangent with each other. We identify where are they, and that's what I'm doing. So therefore, in doing so, in formulating the problem in such a way, for this one effectively fix, we've identify this point. And we can do that. We can do this job for every such point. So, that's a very simple way in formulating the Pareto optimal. We will do it repeatedly. When we consider the production optimal, we are doing quite a similar job. Okay, and let me explain again. We fix up Bob the utility of welfare and see where we should go in order to maximize Alice's welfare. We can likewise fix up Alice and see where we should go to maximize B, Bob's welfare. And so apparently they're not the same problem, but here that's the key point. And let me enlarge a little bit. This is the key point. So what now it's actually doing is to identify the condition for each or for all such points in allocation or for products. So where the two persons in different curves are tangent with each other. So that is they share the same MRS, marginal rate substitution. So, and this is about this Lagrange multiplier lambda. This is about utility or welfare constraint for another member in the society except Alice. And another constraint is the sort of resources for this exchange economy or the product constraint. Sometimes we call this is the endowment. So let me we call this is so in Chinese text, I'm not sure. I think usually translated as 禀赋. Okay, that's what we have. That's given by the God. It's extraordinarily given. We can't change it. So for the whole society, we have such endowment for apples and such endowment for bananas. And this is the big constraint which we can't change. What we can do is to choose the number for apples, which we are going to Alice, and the number, the quantity for banana we are going to Bob. And similarly for bananas. Okay, this is another constraint. So therefore, in this problem, we have three constraints: the endowment and the utility. Again, let me emphasize this part is important. We will do it. We will take this practice when we look at the production optimal. Okay, that's now let's go to the production optimal. Remember, and let me share another file. What's this one? It's not. Give me a couple minutes. Let me share another. Okay. So can you see this one? Okay. And now let's turn to, oh shit, where is, and now let me look at okay. So we are looking at the next step, the next part for the Pareto optimal. This is what we call production optimal. This part, I'm sorry, this term should be here. This word. And okay, we are considering how to maximize, how to organize the social production for this part. Oh, where is it? So sorry, okay, we can't see anything. Okay, give me comment and let me, I try to figure out where that's one. Let me, oh, sorry, give me current minutes. I ask the technician to come over again to fix that.我抓另外一个文件，同学又看不到了，然后
你点开了吗？那个文件
我点开了呀，然后没在这里头，所以要重
重
新
新再来吧。
到这里来。你看看，我打开，然后如何让学生看？打这一个，
对对，
然后呢？
点这个，就切出，
是的，没在这里头哎。
先关掉这个，重新来一次，切出，不是这个吗？
啊，这一个我看看哈。OK， 也我再试试哈，待会儿还有一个。OK， so now it should be OK, right? Oh. It's not OK. So can you see it? OK. Yes. OK. Thank you. Yeah, yes. OK. So, I'm sorry. So much trouble. Let me try to. So it probably I should only use only one file in one class. OK. Now we turn to the production optimal. So we have already basically fixed up for this part. So this part of the problem, this is the production, sorry, exchange optimal. We now turn to the production optimal. As I mentioned earlier in last class or even the class before last one, when we understand what happened for the exchange optimal, it's much easier to understand the production optimal because the idea is pretty similar. And also because what we have learned about exchange optimal is very helpful to understand what happened to the production optimal. You know, if you compare this one with the the exchange optimal formulation, they're very similar. You know, when we consider this part, we focus on Alice. Okay, this is this one. And then make sure Bob will not be worse off. That is, Bob's utility is fixed up. And here, similarly, we consider how to maximize, suppose this is water and this is food. We are organizing for Macro Society to produce production of water and production of food in a way that we maximize output of water, we fix output of food, and then let's see what happens. And we do it, and the constraint, we have this much of workers we call labor. We can allocate the labor to produce X or produce Y, okay? So this is Lx, this is Ly. And also we allocate capital to produce X, Kx, and some capital produce Y, this is Ky. So therefore, this is the constraint on resource, or for capital, this is constraint for the whole society, or for labor on labor resource. And so therefore, when we maximize the output for product X, we can fix up the output for product Y, and to technical constraints, this is the resource. You know, this is very similar to the exchange economy. And the difference is, when we consider this one, the input is X and Y, the output is utility. But now the input is labor, capital. The output is not utility function anymore. Instead is product. So here, remember, X is, we are a little bit lazy. We use X to represent two different things. One, that's the quantity of products. And two, that's also a function. So this you can, if you bother to write more mathematical function, you can write as X equal F, Lx and Kx. F is a production function. But here we want to simplify the mathematical formulation. We just understand this is the function. This is also the output. Okay. And given such Lx and such Kx, that's the input, we have such output. You know, this one, here, that's the apple and the bananas. Here, that's the utility. But the logic is very same. We give some input. We generate some output. Here, that's utility. And when we consider production, input is labor, input is capital, and output is apple and bananas. Okay, and then we go through this problem again. We consider the first order condition. What happened when we consider Lx? How much labor we should use for producing X? And where is Lx? Here is Lx. No Lx. No Lx. Here there's another place, another occasion we have Lx. So therefore, when we consider this one, the first order condition, you will find partial X over partial Lx. So this is the so-called product X, marginal productivity for labor. Okay, when we have used a little bit more labor, we can use a little bit more X. So therefore, the marginal productivity for X is this one. Minus QL. We are using QL. That's that's a Lagrange multiplier. Okay. QK, that's another Lagrange multiplier. And then you get this one. And similarly, you consider capital input for producing X. Again, Lx. So therefore, we get QK. And similarly, consider goods Y. Here is goods Y. LY, how to organize production for good product Y. We get this one LY and another LY here. Okay. And we get this term, equation 3. And similarly, for a capital input or for good of a product Y, we get QY, we get another one. And now, very similar to what we have done about exchange optimal, you just consider focus on X. And when we consider exchange optimal, we focus on eddies, and we figure out the marginal rate substitution for eddies. And here, very similarly, we figure out the marginal rate substitution between labor and capital in producing X. We get this number, and we turn to good Y, we consider equation 3 and 4, we get another number. You put them together, you get this one. Marginal rate substitution is the same. And also similarly, we make some remark. This equal marginal rate substitution between two different inputs and between two resources. Between two goods, X and Y, and between two resources, could be easily generalized or extended for any number, for any pair, for M goods, not necessarily only X and Y. You can have X, Y, W, Z, and so on and so forth. Any number for products, and then you focus on two of them. You consider how to allocate more than two inputs, and then you focus on only two of the inputs. Again, you analyze this problem by focusing on only two inputs, fix up other inputs for the production of every product. Then you get this result. That is X and Y, can be anything, can be any other product. And LK, these two inputs can be anything, any two inputs. This is still true. So, you know, when we consider the exchange optimal, we also remark, we give 3 remarks. And now we put them together, combine the 3 remarks for the exchange optimal into one big remark. So basically, that's generally true, don't worry. So now you can see when you understand this one, it's easy to understand this one. The logic is we are using X and Y to produce, that's the key word, or to generate, to produce happiness. Give some apple, some banana to you. You are a function. You train the input into happiness, okay? And in very similar way that a factory or firm trains some input into some output. So therefore, when you consider exchange optimal, you get some condition. That condition must be true, because we can generalize this part of the story by organizing input to maximize output. Okay, you just consider Alice and Bob, you and me as a machine, right? You know, put it a very straightforward way. We are just a machinery. We are just a machine. We eat, we drink, we take, we consume. Why? Because we generate happiness. And then we enjoy such joy, such happiness. That's all. Very similar logic. Okay. And so therefore, for this one, and now let's put the two optimal conditions all together. And as mentioned earlier, eventually we, you know, the bigger picture, the bigger problem is how to organize everything for the whole macro society. That's you and me. That's a lot of service and products. That's a resource. The problem is We are starting from here. Eventually, we go here. The whole process could be very complicated, and we must do it in the best way. How to do it? Do it in the good way for this part. Do it in the good way for this part. It's not enough. We must produce what we really need. So in other words, we should not be stupid to organize everything beautifully. We did a very fantastic job, very efficiently, but we are producing something useless. That will be very stupid. So therefore, to produce efficiently this part is not enough. We must make sure we are producing what we need, what we want. So therefore, this part, production optimal, solve the technical problem, or we call this a technical efficiency. That's efficient, but in the technical sense. So this part solves the technical efficiency problem. But we need to solve it in terms of economic efficiency. That is, we must combine this one and together with this one. So let me turn to another file. Let me try to that one. Okay, let me try to. You can't see it, and new sharing, and then okay, this is, let me, can you see this one? Okay, good. Okay, and now that's the picture we are now facing. We want to organize everything in a beautiful way, Organize this one, optimal, organize this one, optimal. And now let's put them together. So what's the, sorry, what's the matter here? So the matter, the problem is we are starting from this level. We have a lot of material, a lot of resources. We want to have a good life. We have a good life. And that is, we want to make sure all the mechanism people, the population, all the macro people, they have a good life. Where the good life come from? Come from labor and capital, and then labor capital going through a long process. It's a sort of network. Whatever happens in the middle, we must make sure we turn labor and capital into happiness. Okay, and how to solve the so-called Pareto optimal? And we must organize everything in the way, if Alice is not worse off, how to make sure Bob is as happy as possible. Or if we make sure Bob will not be worse off, how to make sure Alice will be as happy as possible. You know, as mentioned earlier, this is the typical way of argument used by economists when we consider, when we analyze, when we study the so-called Pareto optimal. That's a very simple, a little bit childish. And we basically take somebody as a king, as a queen, and somebody else as a nobody. Okay, just make sure they don't make trouble, basically. Okay, we fix some people or all the people's utility except one person. Okay, nobody will be worse off, but the given person must be as happy as possible. This is very childish, very simple, but at the end of the day, after we complete all the analysis, you will find the result will be the same. If you change and you turn your focus from this person to another, and pretty much like what we have done when we consider exchange optimal, right? You know, as I explained it already at the beginning of today's class. And when we formulate the exchange optimal, we focus on Alice. Take Bob as nobody. Take Alice as somebody. She's the queen and he's nobody. And then we get the optimal condition. And then the optimal condition is independent. It's independent of who we take as somebody. That doesn't matter. Okay, now we are doing the similar job. And now let's turn to the next page. That page will make sample you hate me. And it's look very ugly, very complicated. But I will explain. The idea is pretty simple, but unfortunately, the math part is a little bit annoying, but don't worry about it. Let me turn to the next page. So here, this is not a little bit, okay. And so we focus on Alice. We organize everything, production, and this part we call exchange. But here, that's actually a kind of allocation, how much of X and how much of Y we should give to Alice and Bob. And now, let's formulate this simple problem in mathematics. And after we deal with mathematics, we will deal with the same problem by economics and by graphic analysis. You know, as I mentioned earlier before, I will try my best to explain everything by using 3 different ways: economics, mathematics, and figure. Okay, so let me emphasize this point probably in Chinese, make sure everybody can get the point. 就是我们上节课提到过，我们会尽可能的对每一个问题，对每一个困难的那个分析方法，我们用3个方式一一的说明。一个是纯粹数学的方式，就是算啊算啊。第二个就是用纯粹经济学的逻辑，第3个呢就是画图，直观解释。这样希望每一个同学至少能够彻底的那个懂得其中一个办法，you should everybody understand at least one of the 3 approaches, 3 methods. And now let's turn to the mathematics. Sorry. So here, let me emphasize, I purposely put exchange part into green color and the production into blue color, okay? And so, and in the following, the mathematics part, whenever we have green color, that's meaning about the exchange optimal. When we have blue color, it's about the production optimal, okay? And I hope the color, the different color will help you understand the logic economically. And now let's consider the problem. We fix the utility of Bob, okay? And Bob, the utility is fixed at UB bar, this term. That's a given level for welfare or quality of life. What we can change? We can change everything else, okay? And we can change basically 8 numbers. This number, how much labor going to X, how much labor going to Y. capital going to X, capital going to Y. And also how much X going to B, how much X going to A, how much Y. So therefore, we have 8 decision variables, independent variables. 1, 2, 3, 4, and 1, 2, 3, 4. These 4 variables about exchange. These 4 variables about production. But the real trouble is we must combine, we must put them together, piece together the 2 parts to make a good story. So now let's look at what happened. And this part, again, is about the constraint for the exchange. You know, we just mentioned at the beginning of today. This is after we finish up the social production, Y is fixed. Now just focus on Y, forget about LY and KY. This is just a number, just how many Y we have altogether for the whole society. So therefore, this is the product, sorry, this is the endowment constraint for product Y. And this is how much X, that's sort of the endowment of X for the whole society. So therefore, for this level is about, sorry, this altogether is about the exchange, okay? And plus, this is about how to organize social production. This is about the production part. And now, as mentioned earlier, we have 8 independent variables, decision variables. This part is about exchange. How much X is given to Alice? How much Y is given to Alice? This is how much for each given to Bob. And we figure out the first order condition. Look at XA. Where we have XA, here we have XA. And this part, no XA, right? This part, we have XA. No XA anymore. So therefore, the condition, I mean, this formula is pretty ugly, it's very complicated. But when you come down to first order condition, you will find it's surprisingly simple. It's quite simple because for each decision variable, we have only 2 places, right? So therefore, for this one, we consider partial UA over partial XA. That's marginal utility of for X for Alice. This marginal utility equal gamma X. Okay, minus gamma X equals 0, so therefore equal gamma X. And similarly, for Alice consumption, how many banana to eat, to consume? YA here is YA, that's all. Again, the first order equal marginal utility for banana equal gamma Y. Later on, we will explain what's gamma X, gamma Y. What's the meaning? The meaning is price. But let's, for the moment, assume that's a present. We are not economists. We're just a stupid mathematician. We know how to calculate. We don't understand what we are doing, okay? And if, you know, as economists, we probably somehow you have already got some sense. And even before I explain, what's gamma? That's price. What's gamma X? That's the price of X. But for the moment, let's assume we're idiot. We're just a mathematical genius, but we are economics idiot. We know nothing about it. We know just how to calculate. We don't understand what we are doing. And okay, now let's focus on first order condition. That's about XA, YA, similarly XB. XB here, we have XB. Where is, okay, this one, XB. we have only 2xb in the whole formula. And again, this is the first order condition. The difference from Alice is here we have lambda. So therefore, minus lambda times marginal utility for both in consuming for x. This one equals gamma x. And then this is exchange. When you can exchange for this part, you can easily figure out gamma x divided by gamma y equals uxa over ya. That's marginal rate substitution. This is the exchange optimal. Okay. Here we are repeating what we know already. We spent several minutes in last class and the beginning for today's class on this one. And then for this one, this is about production. Again, let's look at where the labor input for x. Here we have a labor input. If we give this much of labor to produce x, then here no Lx. This is a non-Lx. Okay. And similarly, you will get gamma x time marginal productivity for labor of x minus QL equals 0. So therefore we get this one. And what's this? This is the first order condition for the firm's profit. Okay. If you just recall what you have learned in the intermediate macroeconomics. And do you remember, I don't know who taught you this course. And when you learn about the producer behavior, look at the firm's decision, the firm, why do the people are doing business? Because they want to make money, right? What's money? Money is profit. So where the profit coming from? Using cost to generate revenue. And this is marginal revenue. This is marginal cost. Okay. This is the labor. This is marginal cost for labor. And this one is output times something. What's that? That must be price. Because altogether, that's the revenue. That's the labor cost. So therefore, QL must be wage. Okay. Similarly, QK, that's marginal cost of capital. This must be the capital rate. That's the price of capital. Okay. So therefore, for economists, the picture is very clear, very simple. This is marginal revenue equal marginal cost for X. In organizing production for X, we should organize in such way. Otherwise, we are stupid. We have not yet, achieved optimal in production. And similarly for capital in producing X. Similarly for labor in producing Y and capital in producing Y, this one. Okay, this is, sorry, I should make it even larger. And here, this is gamma, this is Y. They look like a twin brother, pretty similar to each other. I'm sorry for the choice of letters, but don't confuse, okay? Gamma is some parameters, Y is some variables, and so. Okay, and now, again, if we focus on this part, equation 5 divided by equation 6, and this number divided by this number, gamma x, they are canceling with each other. What's left? Marginal productive labor and marginal productive capital equals this one. What's this? This is kind of marginal rate for substitution of labor and capital in producing X, this number. Okay. And this number very similarly, this is for Y. This is the marginal rate substitution between labor and capital in producing Y. They are the same. Again, at the moment, we are assuming we are mathematician. We know how to calculate, but we don't understand what we are doing. Okay, we just put them together. I know you guys both equal to this term. Oh, that's wonderful. You guys equal to each other. But for economists, the picture is pretty clear. Some economic story naturally emerge. What's the economic story? This is the price of labor, the price of capital. So therefore, we have a labor market. We have a capital market. The two markets bring together. That's the key word. That's the key word. Bring together the production for X and the production for Y. So therefore, bring together the two things in producing Y and in producing X. In producing X and producing Y. They must be the same. And who did such a wonderful job? QL over QK. What's that? That's market. But again, for the moment, we just focus on how the optimal solution looks like. And we have not yet tried to understand how to do it. We just figure out where we should go. How to go there, that's another problem. But now, when we explain where to go, I hope as economists, you have already found the answer about where to, how to go. How to go is, let's introduce market. But now, again, let's assume we are just a stupid mathematician. We know how to calculate. We're just a calculator. 我们是个计算器, okay? We're just a machine. We don't understand. And now, this is the most interesting part. This part is about how to organize everything for the whole society. We call top level optimal. That is, we bring together. What's the so-called bring together? Bring together means you should not consider this part independently from this part. Instead, you should somehow mess up. Okay, mess up this part and with this part. How to do that? Let's figure out where to put them together mathematically. Again, at the moment, we just assume we are stupid. We're just a mathematician. We don't understand what we are doing. And how to put them together? Forget about the economic meaning or for each formula. Instead, focus on economics. Here we have gamma X over gamma Y. Gamma X over gamma Y. So therefore, by using gamma X and gamma Y, again, later we will explain probably in next class. That's price, that's market. Okay, now forget about the meaning. Just focus on this one. You know, by using gamma X and gamma Y, we can bring the two persons together, Edison and Bob. We find they share the same marginal rate substitution. That's gamma X, gamma Y story. That's market. Okay, and here we have gamma X, we have gamma Y. And now let's try to figure out how to find gamma X over gamma Y for this part, for the production part. Then if we can find it, we can put this part of the story together with this part of the story. That's a very, very stupid way of thinking. That's mathematician way of thinking, not the economist. But sometimes it works. Let's look at what we can see. If you consider equation 5 and equation 7. Okay. And what's the comma? The comma thing is this number equals this number. QL and QL is the same. Okay. So therefore, if you put together equation 5 and equation 7, QL disappear. What's left? This term equals this term, right? And what's beautiful, what's good about it is we figure out gamma X over gamma Y equals marginal productivity for labor for goods Y and marginal productivity for labor for goods X. Okay, and now gamma X over gamma Y equals this number, marginal rate of substitution. This is about the consumers. This is about the producers, about production. This is about consumption. This is about production. And now, let's turn to what happened with capital. When we organize where we should put the capital, again, either going to X or going to Y. And now let's focus on capital. You will find something similar. Capital QK. So therefore, bring together equation 6, equation 8. QK disappear. We get this one. Again, we have gamma X over gamma Y. So you will find something little bit magical, little bit amazing, little bit strange and special. That is gamma X over gamma Y. Gamma X over gamma Y. Gamma X over gamma is everywhere. Okay, now let's put all of them together. What we will happen? What we will find? For Alice, marginal rate substitution equal gamma X over gamma Y. For Bob, marginal rate substitution. Okay. For labor input, what's this number? What's the meaning for this one? This is what we call marginal rate for transformation. What's the meaning for this one? This is very interesting, this one. And let me check about the time. And okay, we will, because we wasted about 10 minutes at the very beginning due to the technical problem. We will continue for a little bit, for a couple more minutes, okay? Let's try to finish up this part. And for the intuition, we will explain in next class. And also the economic, this part is extremely important. I will spend quite a while, probably 20 minutes. This is about the economic way. And this idea is quite powerful. After you understand this point, I believe, if not everybody, at least most of our class will thoroughly, will clearly understand the whole picture. And now, before we do that, let's finish up this part. Let's focus on what's YL over XL. This one, let me explain a little bit before you go. Give me a couple more minutes. We will finish very quickly. YL over partial Y over partial L. This is marginal labor marginal productivity for Y. What's XL? XL is marginal X over. Okay, so therefore, this one roughly equal marginal Y over marginal X. Partial Y over partial X. As if this term and this term, they're canceling with each other. Of course, mathematically, we can't do that. but we can do it for economic reason. Let me explain why. Just remember what's the meaning for this one. That is, if you are using one more labor to produce Y, how much you can produce. This is if you are using one more labor, how much X you can produce. So therefore, if we produce less X, okay, then we have to save some labor. And we put the labor we such saved to produce a little bit more Y. So we get this number, okay? We change X, decrease X, then we save labor. We put the labor to produce X, then we can increase Y. So therefore, this number must be negative. And the absolute value for this term is if we give up 1x, how much Y we can get. So therefore, this is the marginal rate of change. The marginal rate of change between X and Y. We call marginal rate of transformation, as if we turn X into Y directly. Okay, so therefore, what's this? This is about production technology. This is about who we are, about our preference as a consumer. So now we bring two things together. This is about the production, Alice and Bob, all the mechanism people. And this one is about our production technology. If we give up 1x, how much more Y we can get. So therefore, this is about the purely technical stuff. This is about the human being, about you and me. And suddenly we bring together. That is the technical part, and we are finished up in 1 second. This is about the production. This is about the human being. We finally find the beautiful solution. This is the optimal solution for the top level problem. This is the top level optimal solution.
对吧？对吧？
什么 What are you seeing? Okay, and okay, so now we have to conclude. It's now the time for you guys to go. I know some students have class at 1 o'clock. Okay, and the next class, we will explain a little bit more on this point, and then we spend much more time on this intuition. This part is very important. Okay, and then we have already basically finished up the study for Pareto optimal, exchange optimal, production, and the top level. And the next class we will discuss, come back, go home, go back to economics, discuss economic intuition, economic logic by using some graphic illustration. And I will give you more examples and about all the 3 level optimal and make more discussions. Okay, so that's all for today. Again, really embarrassed for the technical problem. Okay, any question before you leave? I really appreciate very much the feedback from Fanny and some other students last class. You can ask in Chinese if you feel comfortable about it. Any question? I can't see your face. And does anyone have any problem, any question, anything to see? Okay, Fanny, it's okay now, or? Okay, let me see. OK， 实际数字的例子 ，very very thanks thank you. OK, one student asked me, can you give me 有一些实际数字的例子吗 ？OK, I will do it. And again, you know, this part so far we just talk about theory, a sort of theory. And at the end for study for this topic, for the about optimal, I will focus on examples. We will give you several examples by using some what you call 实际数字的例子. Okay, some numerical number. We will do that. Don't worry about it. Any other question and suggestion? Thank you. I really appreciate it. Whatever feedback you can offer, you can give to me. Any other? If no, thank you. That's for today. I will terminate the whole program. Okay, thank you. Goodbye. Take care, everybody.